Hey guys, so our next unit here is going to be logs and exponential functions, okay? So of course the logs are going to just sound really unfamiliar right now, but exponential should be something that you've done before. The last couple of years, you should have been doing a lot of properties and being able to picture the function. Remember, it's like that flat J with a horizontal asymptote. So our first lesson here is we're going to remember what we know about exponentials. Pretty much not so much the graph at this moment, but we're going to review our properties, right? Our properties, and we're going to do a little bit of solving with common bases, okay? So hopefully some of this sounds familiar. So let's just review some of our rules here. So when we're multiplying, by the way, if you remember correctly, if I put the function e to the x would be our base, right? So when I say base, um, that's what I mean. And when I say exponent, that would be the a right here. So that little number right on top. And remember, exponents means multiply by itself that many times. Multiply the base by itself that many times, okay? So rules we have to go through. Well, if I have the bases are the same and I want to multiply, what I'm going to do is add the exponents. So the base stays the same and I'm going to add the exponents. So 1/2 plus 1/2 is 1. Okay, just like if we divide, we're going to subtract the exponents. And remember, the base has to be the same. So if we have v divided by v, well, I'm going to take that v and I'm going to say 1/2 minus 3/2. 1/2 minus 3/2 is -2 over 2, which of course can reduce to v to the -1. Okay. Now, in the long run, though, when we simplify exponents and everything, we need to make sure that we don't have negative exponents. So I'm going to actually, considering we just got v to the -1, I'm going to skip down here. So when you have a negative exponent, it means that you need to change its location. So if it's on top, meaning the numerator, which it is, the way to make it positive is to put it in the denominator, but with a positive exponent. If it were in the denominator, just like this one right here. Again, I don't like the negative exponent, so I'm going to change its location, put it in the numerator, and then make it positive, okay? So the way I used to teach this was we have two rooms. We have the upstairs and the downstairs of your house, right? I think of this like emotions, right? If you're happy in your room upstairs, would you leave your room? No, you're going to stay there. But if I'm upstairs in a room and I'm unhappy, I'm feeling negative, I'm not going to stay in that room. I'm going to leave the room to become happy because I'm in a different place. So sometimes that's how I remember what to do. Okay. Now, here's the other thing. If we have a power to a power, an exponent to an exponent, what we're going to do in this case is we're going to multiply them. Now, I'm not going through this from the very beginning because you should have done this for the last 2 years. So in this case, what I'm going to do is say n because that's my base, and I'm going to multiply these two fractions. 3/2 times 1/2 is 3/4. Remember, multiplying fractions, you multiply the numerators, multiply the denominators. Okay, same thing here. I mean, we still have two bases right here, and they're both going to an exponent. We can actually put those in play to both top and bottom. So here I have an exponent to exponent, exponent to exponent. Wait a second. There are different things that we can do here. Instead of doing what we did here, since they have the same base in this case, Why don't we do division? Well, x to the 1/2 divided by x to the 1/2 is 1, and 1 to the 3/2 is still 1. That was a bad example. Hopefully we get through one and our other examples there that we can go through. Okay, here's another one. Anything to the 0 is always the value of 1. Anything to the 0 is always 1. I mean, and that makes sense here, right? Because anything over itself is 1. We'll go through that in a bit. Okay, the other thing you learned last year was how to change a fractional exponent into a root. Okay, so what you need to keep in mind is that the denominator will be what root you're using, and the numerator will still be in the exponent. So if I were to do this and change this into a root, this would be the square root, which I know I don't have to have that 2 there, x to the 3rd. And really, we're remembering this because we might need to go backwards. So remember, the root is going to be in the denominator. So let's do some practice and see how much we remember. Okay, so here we're dividing. Remember, what did we do with division? Have the base the same, and we're going to do what to the exponents? We are going to subtract them, which gives me x to the 11th. Done and done. When we have power to power, we multiply those powers, those exponents. So our answer is a to the 20th. On k, as you can see, we have a negative exponent, so we need to make that positive. So what we're going to do is stick it in the basement, that denominator, and then it becomes happy. Some people are happy in the basement there. When we multiply, what do we do to the exponents? We add them. Okay, so this is x to the 11th. I made an h. Oops. Okay, now here, when we're doing multiple variables, multiple bases, remember you can only do it to the same base. So when I look at this and I see the division, remember division is we're subtracting. So I go 40 minus 11. And for y, I do 46 minus 22. Okay, so our answer is x is what? 29, x to the 29, y to the 24th, and that is our answer. Okay, now with 6, I'm going to do this in step by step, but really you can go straight to the answer if you get the concept right away. So considering I have this squared, it means that I can square the top and square the bottom. Now on the top there, the numerator, power to power means I multiply. So 3 times 2 is 6, and 4 squared is 16. Awesome. So hopefully these are coming back. Now, our biggest thing, which might have been a little bit harder to remember, is now we're going to solve. Okay, now the only reason you would use your calculator is if because you're trying to change the base. And this is the whole idea. You see how on both sides of the equations we have a base. Okay, so what we're going to do is change the base to be able to solve. Here is the idea. You want to get the same bases. Okay, this is the very important thing, same basis. Okay, so right away I'm going to ask you, what number times itself do they have in common? Okay, 4 and 2. What's a number that times itself they have in common? Well, 4 is 2 squared. Do you guys see that? 2 squared. Now, what was already there was an x, so I'm going to make sure to keep that x there. And I changed this base to 2. Well, this one's already 2, so I can keep it the same. Now let's go back to our exponent rules. So exponent to exponent, we multiply. So this is actually 2, and the 2x equals 2 to the 3. Okay, now when the bases are the same, you can focus on the exponents. So really what we're looking at is 2x has to equal 3. And when we solve, well, we should be really pros at this by now. That means we're going to divide. So x is 3/2. Okay, and then you can always check that on the calculator. You could say 2 to the 3rd, which is 8, by the way, and then you can do 4 to the 3/2, and you'll find out that's 8. Okay, so you can always check your answers with solving. Okay, magical question that I will always ask you. What do 9 and 27 have in common? Now, most people are going to be like, well, 9 times 3 is 27. Again, we're looking at what number times itself could be 9 and 27, which would be, in this case, 3. 9 is 3 squared. And remember, there was already the 2x there. 27. Now, if you do not remember how to get how many times 3 to whatever is 27, let me get a calculator. I'm going to show you how to do this on the screen. Okay? Okay, so since I know it's 3, what I will do is 3 times 3. So I know 3 squared is 9. Let's try it again. Times 3. Oh, there's my 27. So how many times did I multiply 3 by itself? 3 times. Okay, so this would be 3 cubed. Now what was already there? X plus 1. Remember that when you do power to power, you're multiplying. So 3 to the 2 times 2x is 4x. Now be very careful here because this has to go to both of them. So when I multiply, I have to distribute that out. So this will be 3, let's see, 3 times x is 3x, and 3 times 1 is 3. Okay. Now that the bases are the same, I'm able to focus on the exponents. We have 4x equals 3x plus 3. And now it's like 8th grade all over again. Solve for x. Get x's on one side, so I'm going to subtract 3x from both sides. Okay, so that gives me 4x minus 3x is x. So x equals 3. Again, you can plug this on the calculator and check this out. So this would be 9 to the 2 times 3. That gave me this number. And then we can go 27 to the 3 minus 1. And what happened? Ooh, why? What did I do? What happened? Let me check my stuff. So 3 squared, 4x, 3 cubed. Oh, this is why. Did you guys see my mistake? See, I knew I made a mistake there. Get negative. So this would be a negative 3. Common mistakes. Look at this is why we check our work. So this is going to be 9 to the 2 times negative 3. And this is going to be 27 to the negative 3 minus 1. Let's see what happens. Now I got the right answer. This is the great thing about checking your work, right? I made a stupid mistake writing it down. I didn't even do a mathematical mistake. I wrote it wrong. So let's see if we can continue without making mistakes. Okay, so what number times itself would give me 25 and 5? Well, hopefully you were saying 5. 5 squared is the same thing as 25, and x was already there. And hey, we're already in 5s, so let's keep this as 5. By the way, that's why you should never do pen. Okay, so this becomes 5 to the 2x equals 5 to the x plus 2. So we get 2x equals x plus 2. Because remember, once the bases are the same, we can focus on our exponents. And let's solve. Let's get x on one side. So we'll get x equals 2. Okay? And again, you can plug in and solve. I know this is correct, but you can check it out if you want. Okay. Now, number 4 here, 16x plus 1 equals 4 to the 2x. What do they have in common? Okay, well, actually, they have two things in common. So you get to choose what you want to do to change your base. The easiest one right now is I know 4 times itself is 16. So I'm going to keep it in the base of 4. Could you have done another thing? Yes, you could have done 2. 2 to the 4 is 16, and 2 squared is 4. So either way, you'd come up with the same answer, okay, guys? But I'm going to stick with the easy one, which is 4. So 4 squared is 16, having the x plus 1 there. And hey, we're in the base of 4, so let's keep it. Now, remember, again, I'm going to multiply everything. Distribute the x and the 1. So this is going to be 4 to the 2x plus 2 equals 4 to the 2x. So now we have 4, let's see, focus on the exponents. So we get 2x plus 2 equals 2x. So let's solve. Okay, so let me move this 2x over here, right, by subtracting. If we did that, we get 2 equals 0. Wait a second, the x's canceled, and this makes a false statement. So guess what? What happens? That means since this is false, this is no solution. There is no x value that makes this work. Okay? Trickiness. Okay. Now, when we went over our exponential rules, where have we seen fractions before? Where did we see fractions? If you go over to the other side, where's the first time you saw a fraction in the case of moving? Well, if you remember, it's going to be our negative exponents equals our fraction, right? Okay. So if we were to go backwards on this, let me rewrite this and get rid of the fraction first. What this means is that this is going to be 2 to the negative 1. Now, how did I know it was going to be 1? Well, 1/2 is actually 1 over 2 to the first. And then I move it up, and because it was happy in the basement, it's now going to be sad or negative in the numerator, okay? And now it looks like one of the ones we've done from 1 through 4. What does 8 and 2 have in common? A lot of people are going to say 4, but that's not it, right? It has to be a number times itself, because 4 times 4 is 16. It's not 8, right? So the answer is 2. And again, if you don't know how to get 8, you go 2 times 2 times 2, and up, there's our 8. How many 2's did we use? We used 3 of them. So this is going to be 2 to the third times 2, or to the 2x equals 2 to the negative 1. Multiply that out, so this is 2 to the 6x equals 2 to the negative 1. Focus on the exponents, so we get x equals negative 1, 6x equals negative 1, so x equals negative 1/6. And you are done. Check your work. Next one. 27 and 9. Well, great thing is we already did number 2, right? So we already know it's 3. So 27 is 3 cubed to the x equals 3 squared to the x plus 1. Don't forget to distribute there. So this is going to be 3 to the 3x equals 3 to the, well, 2 times x is 2x, and 2 times 1 is 2. Focus on the exponents. 3x equals 2x plus 1 plus 2, sorry, craziness. And then solve for x, so we're going to move the 2x over, giving us x equals 2. And we are done. Okay? Okay, let's get into more complicated questions. Now, I also added these two down here. I probably don't have much room to do it, so we'll see if I can save some space up here. Okay, so right away, I see my base is 4 and 16. What do they have in common? Again, you could use 2 if you want to, but you can also use 4, which means this is already in the base of 4. 16 is 4 squared. So this is 4 to the negative 2x equals 4 to the 2, which means focus on the exponents. So we get x equals negative 1. Okay, again, plug in if you need to, double check your answers. All right, number 8. Ooh, we have 3 bases of 5. What you need to do, because every time we've done this where we focused on the exponent, you see that you have one base on the left and one base on the right that are the same. Here we have 2 bases on the left, 1 base on the right. So what we're going to have to do is combine the left side together. I see here we're multiplying, right? What do we do with multiplication? What do we do with the exponents? We should be adding them. So this is 5. And I'm going to write this next step out. You don't have to if you can do the math quickly. Remember, I'm going to go x plus 1. Okay, now I'm going to simplify that. And of course, I'm doing this so you can remember that multiplication means we add the exponents. So this is going to be 5 to the 2x plus 1, combined like terms, equals 5 cubed. Now that they are the same, we can focus on the exponents. So we get 2x plus 1 equals 3. Let's solve. Subtract 1 from both sides. Divide by the coefficient. 2 divided by 2 is 1. Plug in if needed. Okay, same thing. Ooh, this isn't even a solving one. This is just a simplifying. Remember, solving means equal. When we don't have an equal side, we're simplifying, okay? And if we're simplifying, I see that the bases are the same. This is a good start. And then I see that it's division. So what do we do with division? We subtract. Now, again, I'm going to do this step, especially because I have this exponent, this 2 terms, the binomial in the exponent. So this is going to be 2x minus this whole exponent. So I need to put in parentheses there, okay? Because what's going to happen is I'm going to have to distribute that negative out. So this is 3 to the 2x minus x plus 1. Now I'm going to combine like terms. So 3 to the 3x plus 1. And we start right there because we're not solving, we're just simplifying it, okay? These 2 questions I'm adding in because there's an extra step. Okay, there's an extra step to this, and I want to make sure we go through it. So as you can see in all of the questions above, we've had a base and a base on the other side, or a number that we changed into a base, right? Well, there's some extra pieces here that we have to deal with before we change the base, because I see this base is 3. Okay, but on the calculator, if we try to go 3 times 3 times 3 times 3 times 3, we won't get to 162. And there's a reason. Because I can't change the base until the base is by itself. So see, every time I change the base, right, the base was by itself to an exponent. Here's the thing. We have an extra 2 right here. 2 is doing what? It's multiplying. You cannot multiply these 2. Do not multiply. Okay, but how can we get rid of multiplication? We can divide. So I'm going to divide both sides by 2. When I divide both sides by 2, I end up on this left side with 3 to the n equals, and in my calculator, I'm going to divide by 2. So 162 divided by 2 is 81. Okay? Now I have to change the base. So again, maybe you don't know this off the top of your head, which is totally fine, so I'm going to use my calculator. 3 times 3 is 9. So there's 2 of them. There's 3 of them. And there's 4 of them. Okay, so 81. So this is the 3 to the n equals 3 to the 4th, which means n equals 4. And we are done. Now, same idea here with this one, except what is our extra piece of information? Our extra piece was this 2 right here, correct? Okay, so our extra piece of information right here is this minus 10. So we need to get rid of that. Well, how do you get rid of subtraction? We add. So this is going to be 5 to the 2x minus 1 equals, and if I add 10 here, I get 125. Okay, I'm actually going to move this over here. Okay, so we have some room. So right now I'm going to change this 125 into a base 5. So again, if you don't know off the top of your head, go 5 times 5, that's 2, times another 5. Oh, there's only 125. How many 5s did we do? 3 5s. So this is going to be 5 to the 2x minus 1 equals 5 to the 3rd. Okay, our bases are the same, so now I can focus on the exponent. So I have 2x minus 1 equals 3. So let's solve. So we get 2x. We're going to add 1 to both sides. And then we're going to divide by 2. So x equals 2. And you are done. These are the types of problems we're going to practice today. Okay, remembering our exponent rules and then solving by change of base. Okay, let's do some practice right now. See how you're doing.